12 people. I think some people thought this whole week was like fall break or something, but it is not. Oh, yeah, I got it. So I got to take a look at that. Don't worry. All right. Yeah, I just got it. Let's see. How's everybody out there? Any questions, concerns, comments, specific, general?
Yes, Professor.
Yes.
I have a question in section 3.10. Question number 5.
310. Where's that at?
It's page 37.
437. Number 5?
Number 5, yes. The equation we write in 2, 3, and 4. It's need to be written in 5.
Yes, exactly. So you have 2 equations you've written, and that's the 2 equations you have to use here. Right? You
that's
have
it. Just
yeah.
to write it.
Oh, Sam, it's a little bit. Your Wi-Fi is a little bit good, come in and out, but yeah, the equation you got for number 3 and the equation you got for number 4, those are the 2 equations you used here. You're just trying to compare them to see when is which one better than the other one, really.
Yeah. Got it. Thank you, sir.
You're welcome. All right, how's everybody else?
In section 4-5 on 528, I'm just kind of concerned that I may be doing some of these wrong, just the way it's worded. So when it's how much is he earning when he's 35, is that also including like his investment income, or is that going to be separate?
Yeah, they don't do the greatest job here because they have earnings. Wait a minute, let me see. Yeah, they have his job, how much money he's making in his job. Then he's saving his earnings, so he's getting interest on that. And then, of course, there's his expenditures, but they do a piss poor job of explaining that when they say his earnings, I don't believe they include the interest. Yeah, they don't. They should just say, how much is he making at his job? Do you see what I'm saying?
Okay.
That's a good question because it's on them. I'm like, if I were you, I'd be saying, well, he's earning money in his job and he's earning money through his account. But they really mean specifically at his job, yeah.
Oh, okay. The only one that seemed like more clear was just number 6, where it said how much he was earning in salary.
There you go.
The other ones are just kind of fuzzy.
I agree. So each of these problems, they're being specific about one of the things. Yeah, one of the 3 things. Let me see. Do they ever bring it all together? No. Blah, 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 blah. Yeah, okay. All right. How's everybody else? You guys all right out there? Anything else? Okay. All right. I'm gonna be optimistic about that. My normal optimistic fool self. Say that means everything's going great. I don't know if you guys noticed. It was just this morning I did this, but let me show you. I did put up on the Canvas site. I put up a little something. It pretty much mimics what we did yesterday. So if you go to Unit 4, there's a factoring motivation sheet, which is kind of funny to me. It makes me feel like I'm a theater teacher. What's my motivation here, teacher? No, motivation is passing. But I call it factoring motivation because it goes through the same steps we went through in class, right? Remember doing this? Coming up with numbers that multiply by this, add to be this. And then this is really interesting about math. We're trying to create a process where I can do this problem backwards. So of course, a good first step is to do many of these problems and then see if there's a pattern. And then try to capture that pattern and make it a general process. Are you guys sort of with me? That is what we did yesterday, but I think it might be a decent thing to do a couple of these and get caught back up with what we did yesterday. So let's go ahead. Let me pull this up in a different way so I can write on it. But if you can go into Canvas, factoring motivation in Unit 4 module, you can pull that sucker up. I'm going to pull this up in a different way so I can write on it. Let me see. Did I get that ahead of time? No, Jeff. You crazy person. Oh, it's right there. Sweet. All right. All right. So let me put this over here. And I just want you guys to do the first couple of these things. I'll kind of build back up to it. There we go. You guys can see it again? Okay. So try to do these things. I know we did these yesterday, but the more you do of these and the more you see me do them, the more you see what you can do, what you're allowed to do. Oh, crap, I got to set that up. Let me see. Okay, why do I have George Michael song in my brain? That's interesting. All right.
Bluetooth mode.
Really?
Bluetooth.
Oh. Let's see, where am I? Wow. Hello. All right. Wow. That's right up in your face. And again, I really do think, I think this is a true statement, that people don't mind this kind of problem, these kind of problems. These are semi-interesting. They're not algebraic problems. They're just kind of playing with numbers, right? Who's got this first one done?
3 and 8.
8 and 3.
3 and 8.
I mean, 8.
Kick ass. You're good. Yeah. So 8 times 3 or 3 times 8, I'll accept it either way. That's 24. And then 8 plus 3 is 11. So the two numbers are 8 and 3. All right. So that's something we could have done day one of this class, right? I could have just threw this at you day one of this class and you would have been like, I can do that shit. I have no idea what this has to do with anything, Jeff, but I could do it. Right? This is just playing with numbers. That's all this is. But then we immediately see the usefulness of this skill. This one's a little bit more interesting, but I think we did something a lot like it yesterday. What's going to have to be true about the two numbers, since they multiply to be negative?
One of them has to be negative.
Yes, and I want you to really understand what I'm about to say. I still want them to add to 6, but since one of them is negative and the other one's positive, they actually subtract to be 6. They have to be 6 apart from each other, right? Now this one's not too horrible. You could probably tell what it is semi-quickly from negative 40. Right? I don't know. Let me give a few more moments. Has everybody got the answer? Don't say anything. Don't say anything. All right, go ahead. What you got?
Negative 4 and 10.
Yes. So the smaller one has to be negative so that it adds to be a positive 6, right? What if I had said two numbers that multiply to be negative 40 and add to be negative 6? What if I had said that instead? Multiply to be negative 40 and add to be negative 6.
Just be the other way around.
Yeah, it would have been 4 and negative 10. The bigger one would have had to be negative so that they add to be negative. Are you guys with me? Don't let the negative come off like extra shit to worry about. No, the negative is trying to help you. Believe it or not. So when they multiply to be a negative number, they are opposite signs. The two numbers that are the answer are opposite signs. Therefore, whatever they add to be actually means they subtract to be that because one of them is negative. So this problem, multiply to be negative 56 and add to negative 1. So I know I need two numbers that are 1 apart, like 4 and 5. If the 5 is negative, they add to be negative 1, but 4 times negative 5 is not negative 56. Is everybody semi with me? You do not have to do it the way that I'm talking about at this moment. I'm trying to throw at you several different ways to think about this problem.
That's good, Jeff.
Sorry, go ahead.
I said, that's good. I right away got the answer when you said it like that.
Yeah. So it's you can play the two things off of each other. You know two things. You know they got to multiply this and add to be this. So why not kind of use both? All right, they got to be 1 apart. So have that in your brain. And they got to multiply to 56, negative 56. Right? So what do you guys get for that?
7 and negative 8.
Good. 7 and negative 8. The bigger one is negative so that it adds to be negative. All right. So what the hell does that mean about anything? Well, we eventually get to the point where if I had a problem like this, see, where do I have some room here? Yeah, I'll do this first one. If my problem was x squared plus 11x plus 24, you guys with me? Then the real problem of factoring this, once I write x and x, because that makes x squared, of course, this becomes my real problem because now I just got to figure out what numbers go here. And now we know the numbers that add to be the middle dude and multiply to be the last dude are positive 8 and positive 3. So the idea of factoring a trinomial, oh shit, I don't know if I've said that word yet, but this has got 3 terms, right? So it's trinomial. The idea of factoring one of these bad boys, crappity doodah, there we go. Come on, pen. When the first number is a 1, you guys notice that? The first number has to be a 1. The idea just boils down to this number puzzle. That's it. That's what it boils down to. It's too nice. And again, I've kind of leapfrogged a little bit. These problems are what we did yesterday to show the idea that that's why the middle number is the one I have to add to b, because that is what happens. 4x plus 5x makes the middle number, and 4 times 5 makes the last number. That's why this is the one I got to multiply to b, and this is the one I got to add to b, because that's what the hell happens, period. Not because some stupid math dude sitting up on some rock said that shall be the way it's done, but just because it's the freaking thing that happens. Right? I feel like math is of the people, the common people. Shut up, Jeff. All right. So let's kind of jump down here. So on part A, so you know already it's going to be x. Why am I giving so much room? Damn. You know that already because x squared would be x times x. That's the known piece. Don't yell the answer out. I know some of you guys already know the answer. The unknown piece is what numbers go here and here. What do the two numbers have to do? They have to add to be what?
Add to be 8, multiply to 12.
Yeah, add to be the middle term, the middle coefficient. Multiply to be the last number. Because that, again, is what freaking happens, right? So these numbers are nice. What are the answers then? What adds to 8 and multiplies be 12?
6 and 2.
6 and 2, 11. Do I have to put the plus 6 first?
Not necessarily. It'd probably be the same, right? Okay.
It's the same thing. Either way, I would take either way, of course, because what's true about multiplication, it's commutative. You can switch the numbers around. 7 times 8 is the same thing as 8 times 7. This poor little parenthesis gets lost over there. There we go. All right, let me show you a little side note. Maybe I'll do it over here. I got more room over here. Try to do part B. If some of you guys have a different way to do this, I kind of want to see your way to do it. We're always curious about other teachers and how they teach this kind of stuff. Good Lord, Jeff. What do these two numbers have to add to be part B?
-10 and -2.
No. They have to add to be -12.
Yeah.
And they have to multiply to be +20.
Yeah.
And the only way that they can multiply to be a positive is if they're the same sign. Are you guys with me? So like Wasan just said, they have to both be negative. And I think maybe you guys can just see the numbers aren't too crazy big. So -2 and -10 is correct because -2 times -10 is 20. -2 plus -10 is -12, right? So if this sign is positive, if they multiply to be positive, they have to have the same sign. If they multiply to be negative, the two numbers have to have different signs. So try to do part C. Part C is going to be a little more challenging. So of course, these have to add up to be -11 and multiply to be -60. So let me show you the way. 60's got a ton of factors. You guys with me? 60 is one of those numbers you can break it up so many ways. So you could take -60 and start breaking it up, right? So here's what I would do. I would say, all right, they got to multiply to be a negative number. So they are different signs. So I need both of them to be 11 apart from each other. So for example, aren't 3 and 14, aren't they 11 apart from each other? If I make 14 negative, what do these add to be? -11, right? Do you guys see that? But what do these multiply to be? If I multiply these, I get negative 42. So then I go, okay, what about 4 and negative 15? See how I just made each one of them go up by 1? Now there's still 11 when you add them, right? There's still negative 11. You guys see that? But what's 4 times negative 15? That's right, kids. Negative 60. And that's exactly what I need. So I really, really want you guys to understand. You need the two numbers to do these two things. Who cares which one you make them do first? Does it make sense? You don't have to make a big ass list of factors of 60. You can actually just start with, let me make a couple numbers that are 11 apart and then multiply them and see if they make 60. I don't want to make the big ass list of factors of 60. In fact, 4 and 15 is something that people wouldn't even think about for 60, right? It's not the first thing I say factor 60. I don't think 4 and 15. I don't.
That's neat. That's real good there, Jeff.
I like it. Thank you.
You just went up one. You just went up one until you got to that number. Yeah, that's good.
Yeah, if I have two numbers that are 11 apart, and then if I just add ones to each, like, you know what I mean, make them go up by 1 and keep going up by 1, they're still going to be 11 apart, of course, right? And then that makes it real quick. I just throw them in the calculator and see if they multiply to be right thing, and this one does. It's just quicker. It's not better. It is quicker, but it doesn't mean it's better. If you would rather just do this, if you would rather just write down the factors of 60, so like 2 times 30, but they would never add to be 11. I don't care what you do, right? You guys see that? 3 and 20, but they would never add to be 11. 4, and you put it in your calculator and you see, oh, it's 15. Oh, good, there it is. All right. That didn't take long, but I still want to show you different ways to do it so you can pick which way makes the most sense to you. Now, just to remind you guys about a couple things. Well, shit, you went and took up all my space, didn't I? I sure did. So here, let me try to remind you guys about a couple things here. One thing is, well, shit, I never did write the answer here. What's the answer to this now? I love it. What's the answer here? What do I put in here?
You did. It was negative 15 and 4, right?
There you go. I just never wrote. This is the answer. The two numbers are not the answer. This is the answer. Do you guys understand? So never stop here. This is what, so this factors to be this. So can somebody tell me, let me bring this idea back. What are the zeros of this function? What are the zeros of this thing? I'm gonna put in ES like heroes. What are the zeros?
15 and negative 4.
Totally, you guys remember that? So if this was somehow related to a profit function, these would be where I would break even. Whatever they mean, this could mean 15 months from now and 4 months ago or something, you know, whatever the units are in the problem. Are you guys at all with me? Okay. Here's the other thing. Oh man, I got so much stuff written down here. It's insane. Let me erase some of my, it's almost like choreographing a football play. All right. Remember this little thing. If X was, what, Jeff? If X was 10, right? If X is 10, where'd that come from? From my brain. You can make it whatever you want to. Is this a part of the problem, Jeff? Nope. Nope. This is me doing extra shit like I sometimes do. If X is 10, this is 100, right? X squared would be 100. 11 times 10 is 110 minus 60. So I get negative 10 minus 60 is negative 70. Is that cool so far? Again, why was it 10? It could have been anything. I just picked 10. Nobody said anything. So I picked 10. Nah. What are you doing this for? I don't know. Oh yeah, to see if this is right. to be honest. This is another way to check this. So what does this become if x is 10? 10 minus 15. You guys really aren't helping now. And then 10 plus 4.
14.
And hey, look at that. So that's almost the same thing, right? And what is negative 5 times, get out of there, it doesn't mean anything. What is negative 5 times 14? Negative 70. So what we did here, like I said yesterday, is we factored every number that this guy would make. You make x something, it becomes a number. What's this? It's a way to factor that number. Whatever value you make for x, the answer we got would be a way to factor it. So that's an infinite number of numbers we factored. It's crazy. All right, maybe. What's wrong with problem D? Is there something wrong with this dude? How is it different from every other problem here?
There's an 8.
8 doesn't matter.
You got a number squared.
I got a number that's not 1 there, right? And I want you guys to understand the process we use here needs it to look like this. B can be anything, C can be anything, but the first number has got to be a 1. Well, what the shit, Jeff? You made this thing. You made this worksheet. Why did you put a 2 there? Well, because can I take a 2 out? Can I undistribute a 2? Does that make sense? Like if there was a 2 in front of something, what would have been inside to lead to this? 2 times what? Say again, I'm sorry?
It would be 4x and 4.
At the end, sure. But what about at the beginning? Oh, shit. I keep hiding these things. What would have been here so that I would get 2x squared there?
X squared.
X squared. There we go. So let me write this again. So I get 2. So what I did there, do you see why I love to call that undistribution? Distribution is bringing a 2 in. Undistribution is taking the 2 back out. And what do I have in here now? Don't I have something I can attack with this process because it's got a 1 here now? So I'm going to write my 2. It just comes for the ride. I need 2 numbers that do what? You can't go wrong here. 2 numbers that do what?
Add to be 4, multiply to 4.
Yeah, what are the only 2 numbers added before and multiplied before?
2.
2.
So there you go. There it is. And just in case anybody's curious, you could actually write this as this. Right? Because what's something times itself? It's that thing squared. Do I need you to write it like that? No, I don't. Can you write it like that? Yes, you can. So try part E. Part E shouldn't be too freaky. Ouch. When the night has come, the land is dark. Yeah, Jeff, you dance like Donald Trump. That boy's got no rhythm in his soul. He might not have a soul. Anyway. This one is a lot like the problem above that Linnell gave me high marks on for how I explain it. Because see how the middle term is a -1? So the two numbers here have to add to be, oh shit, what do I got? Somebody telling me the answer. Oh, it was a bird or something, right? Or something, something has walked across somebody's keyboard. Okay. I can't remember what that was. All right. Add to be what? What do they have to add to be?
-1.
-1. I love it. When there's no number there, we know it's a 1. There's an understood 1. And they have to multiply to be
-72.
-72. Cool. So they have to be 1 apart. So like 7 and 8, but that's 56. What about 8 and 9? Yeah, there you go. I like it. I got double thumbs up there. 8 and 9, which one is going to be negative?
The 9.
The bigger one, so that they actually do add to be -1. So it'll be +8 -9. And again, if you wanted to, you can write it the other way and you're fine because multiplication doesn't give a shit. Multiplication is chill like that. Has anyone tried F yet? Can you immediately see that F will not work? What has to happen? I need two numbers that add to be 3 and multiply to be frickin' 7. 1 and 7 make 7, Jeff. There are other things that multiply to be 7, but they are not nice numbers. So am I saying you cannot factor this? No, you actually can factor this using exceptionally freaky ass numbers. So normally when I say factor something like this, I mean factor it using integers, whole numbers, right? Maybe some negatives, but so what would I call this? What do I call a number I can't factor?
Prime, that's a prime number?
Yes, exactly. That's a prime expression. Now here's what's funky. Let me see. This might be going too far. That does not mean that for every value of m, I get a number that's not factorable. That is not what that means. What that means is this is not factorable for every value of m, so therefore it's prime. Don't worry too much if you didn't quite get that. It's a little bit in the weeds. So here's the next thing I want to, is everybody cool with any questions on those things? I mean, this should be kind of nice. Especially the more you get this by itself, the more you get this idea of just making the numbers work, the easier this thing down, all of these are, the easier these are, because that's really all it is. It's a number puzzle. So I want to show you something kind of cool. Let me see. If I switch over, can you guys tell me, do you guys see something nifty now? Do you guys see a red parabola? So I made a little equation over here. Do you see how I made the A 1? Is that cool? Do you guys see how A is 1? You can see, from the equation, you can tell what the zeros are, right? They're 2 and 4. Can you see them on the graph too? You can see, and again, you can see why we call them zeros, because they're on the 0 line. They're on the x-axis. They have an output of zeros. Everybody with me. Where is the vertex? What's the x value of the vertex?
-1. Oh.
X value.
1.
3. Why does that make sense? What is true about this picture? Why is it such a nice graph? Why do we kind of like it? Because it's got what? It's got appeal, Jeff. It's got that thing. No, stop it. If I fold it on itself, it perfectly matches. That means it has what?
It's symmetrical.
It's symmetric. I love it. Boogie, woogie, woogie. In fact, let me see if I could do this. Here, Desmos, can you handle this? Yes, you can. So there, I just put a green mirror in, right? Isn't that the mirror? Doesn't that mirror go right through the vertex? And doesn't that make sense? The vertex would be the point that's on the mirror, and then it's a mirror image on both sides. So where will the vertex be always? If I know the two intercepts, the vertex has to be where? Right in
The middle.
the middle. I love it. No matter what I make this, watch, I made this little slider. No matter what I make this, do you see how the vertex stays on that green line? Right? Now, real quick, why does it make sense the minute I make A go negative, what happens to the picture? You guys see up here the A? If I make it go negative, what happens to the picture?
Flips upside down.
Yeah, it makes sense because now it's negative, so now it's going to be opening down, right? And of course, if I make it 0, that just makes the whole thing die, right? So that's not very interesting. And of course, can you tell also that when I make it bigger, it gets skinnier, and when I make it smaller, it makes it fatter? Whoa! Is there a value that makes it look almost flat? Of course. If 0 makes it flat, then 0.000, in fact, let me put that in. I love this question somebody gave me. So if I make the 0.0001, isn't that close to 0? Look, it looks flat, doesn't it? Do you guys agree that looks flat? Right? The closer that number is to 0, the more flat. But look, if I move out a little bit, do you guys see how it's not flat? Isn't it starting to lift up? Right? Isn't this website cool? This is desmos.com. It's a free thing. Anyway, that's a good question. I like that question. Anyway, all right. So what's my point? So let me do this. If I make this, oh, let's see. Let's do this. What about for this guy right here? Can somebody predict for me what the X value of the vertex will be? And let me get you started. What are the zeros for this?
10 and 2.
10 and 2. Where will the vertex be? At what X value?
In between those?
In between those? And what number is right in between those? Take the average. Add them, divide by 2. What do you get?
Oh,
Negative
6.
1.95.
Whoa, no. I'm not talking about a Y value or something. I'm not sure what that is. If you add those and divide by 2, you get 6.
6.
Totally 6. If you add 10 and 2 and divide by 2, you get 6. Isn't 6 4 away from 2 and 10? So isn't 6 right in the middle?
Yeah, that makes
Maybe.
sense.
Okay, so now watch. X squared minus 12x plus 20. Let me go back here and put in here x squared minus 12x. Oh shit, what was it? Plus 20. And let me change this to 6. Bam. Let me get rid of that. Holy shit, there it is. Yay, there's the vertex. Holy shit, it's 6. So that is the other, I really want you to understand. Why is it so important to know how to factor? Well, because then I can figure out the zeros. And then somebody could say, why would I give a shit about the zeros? Well, because they mean something. They mean break-even point. They mean whatever. I don't care about that. Okay, well, right in between the two of them, you find the other most important point of a parabola, which is the vertex. So if I'm able to factor something, I can see where the zeros are, and then I can tell I know where the vertex sits. All right. Woo! So we can do a lot of shit if we're able to factor these things. I like it. All right, so let me come back to the book real quick. And by the way, this website is it's just nifty. You can start plugging shit in saying, what happens if I do a cubed, not a 30th power, a cubed, plus 2x minus 5. Ooh, that's neat. Let's say plus x squared. Ooh, that's neat. I mean, I don't know. I was the weirdo that would play with a calculator when the tax man would come over to help my mom with her taxes. I said, can I play with your calculator? That boy ain't right in the head. All right. So I think we're done with that. Yeah. Let's come back to the book here. Bam. Let's see. Where am I? Oh, shit. I'm way away from where I want to be. Holy shit. All right. There I am. Weehaw. Give me a second. Let me find this. Here we go. All right. Where was that? Where was that? Where was that? Talk amongst yourselves. Let me see. No, no, no. Come on. Where is this? Here we go. Oh, this is kind of neat. All right, all right, all right. This is kind of neat. Read through that real quick. In one orchard, right up here. Let's read through this. This is really, really, really interesting. We'll find out if it's just me that thinks that. It's okay if it is. I'm used to it. Now think about this. This is actually a simplified, obviously this is simplified, but this isn't too far away from the truth. If you planted another tree, it's going to be using resources that the other trees there could have used, correct? So you will get another tree's worth of apples, but then every tree will make less apples. So inherently, there's a sweet spot. Well, how many trees should I plant then? Because if I plant one tree, I'm screwed. But if I plant 7 million trees, I'm screwed also, because they're not going to be able to give me anything probably. There's not enough resources. So now look. So right now, there are 50 trees. And each tree produces 800 apples? Holy shit. I got to look that shit up. Is that true? I guess that's over their lifetime. I don't know. Obviously, that's not in one day. 800 apples on a tree. All right. Sorry. It's all beside the point. If I plant an additional tree, the average output per tree drops by 10 apples. Bummer. All right. Now watch. Number 16. If X more trees are planted, how many trees will there be total? That's not a hard question. How many trees are there right now?
50.
50. So if I plant X more, how many are there now?
50x.
No, I'm not planting. Yes. I'm not planting X times as many. I'm planting X more. Is everybody with me so far? So X is the number of additional trees, right? So if the current yield is 800 and it goes down by 10 for each new tree planted, what will the new yield be? Oh, this is dumb. I wish they wouldn't have done this, but oh well. If 5 more trees are planted. So if right now they give 800 apples, but they go down by 10 for every tree, every extra tree, how many will there be how much will they each give if I plant 5 more trees?
So 50 less than 800?
Yes. So it's minus 10 per tree. So they'll give 750. Now, it's interesting to me, very quickly, you guys stay with me now. I'm going to do a little extra like I always do. I'm insane. If I have 50 trees and they each give me 800 apples right now, how many apples do I get? What do I do with these? 50 trees, they each give me 800 apples. How many apples do I currently get?
4,000.
Almost.
40.
40,000. You guys with me? That's a damn good number of apples. But, you know, if I could figure out mathematically, can I get more? Now watch. Stay with me. If I do this, if I plant 5 more trees, now I've got 800. No, I'm sorry. What do I have 55 trees now, right? Is that cool? And now they each give me 750 apples. Now somebody help me out. I'm not going to pretend like I can do that in my head. Can somebody help me out? What is that? If you do 55 times 750.
41,250.
So each tree is giving me less apples, but I do have more trees. Did my yield go up? Did my total number of apples go up?
Yes.
Yes. So I seem to be going in the right direction. So if I plant 5 more trees and I sell all my apples, am I doing better? Of course. Could I do even better? I don't know. let me figure it out, right? Is everybody semi with me so far? Now 18 is a much more interesting question. So if the current yield is 800 and it goes down by 10 for each new tree, what will it be if I plant X more trees? So think about what we did up here. If I planted 5 more trees, it was 800 minus 10 times 5. So if I plant X more trees, it'll be 800
minus 10x.
Yes. All right, let me stop. This is really some good shit right here. And again, this is simplified, but it really isn't that far away from reality. There are more variables, right? Everybody understands there's more variables to consider. But this is the underlying idea behind what we do anyway, even with the more complicated stuff. All right, so keep track of this. If I plant more trees, X more trees, I have 50 plus X trees. But I get 800 minus 10X apples per tree. Now, what do you think I'm going to do? How did we figure out these numbers? Didn't I multiply the number of trees by the number of apples per tree? Isn't that what we did? Didn't we do that? We took the number of trees times the number of apples per tree. We took the number of trees times the number of apples per tree. Well, I can take the number of trees up here, these number of trees, and I can multiply it by the apples per tree. The apples per tree right down there, the apples per tree. That's exactly what they're going to ask next, I bet. I don't even know for sure. Let me stop for a minute. So these two numbers were too specific. They were assuming I knew how many more trees. I'm going to say, I don't know how many more trees I want to plant. So I got to use this and I've got to use this. All right. So somebody, you guys all have that written down, right? I'm going to need your help in a minute because I got to clear these drawings away. I'm going to clear all this away. You guys ready? Here it goes. Bye, chicken scratch. All right. So look at number 19. Total number of apples produced will be the total number of trees times the yield per tree. That's what we know. We know that. So I guess they want to use the letter T for total apples. I don't know, whatever. It would be 50 plus X. That's the number of trees times 800 minus 10X. Look at you, Jeff. I think I remembered that, right? Isn't that the right thing? The apples per, oh crappity, doodah and a half. Come on. Apples per tree. I have no idea if you guys are still with me. You're all like, really? We're talking about apples? Really, Jeff? Yes. Can somebody find the x-intercepts? Find the zeros is another name for that. What are the zeros of the function we just wrote? Wow, this is interesting. I like this. I won't say anything else. Find the zeros. One of them is easy, right? Can somebody tell me the zero that comes from this piece?
Would it be negative 50 and negative 600?
Sorry?
Negative 800?
No. So here's what we're doing. Here's what we're really doing. We're saying, when is this equal to 0? Subtract 50, subtract 50, x is negative 50. Did I have to do that for that problem? No, because I can just see that negative 50 works. But now I want to know, when is this piece equal to 0? Do you see how that's a little problem to solve? Not your problem to solve. So if I add 10x over and divide by 10, I get 80. Now, what the shit would this mean physically? What would this mean physically? X represents how many more trees. So what would negative 50 mean? You could do it. You could do it. If X is 7, I plant 7 more trees. If X is negative 50,
you lose trees.
I dig up some trees. So the answer could have been, I need fewer trees, right? The answer could be. Now, stay with me. This means that if I lost all my trees, my yield would be 0. Well, duh. But here's the one that I didn't know. If I plant 80 more trees, according to this simplified model, none of them will produce any apples. These are my zeros, right? This is what makes the output 0. This is what makes my yield 0. So if I plant 80 more trees, there's basically not enough resources for the trees. They're not going to make any apples. Can somebody tell me where the vertex is? This gets a little bit freaky. So I got negative 50 and 80. That's where my intercepts are. And the picture looks like this. So somewhere there's going to be a vertex. Huh? Sorry?
15.
15. How'd you get that?
80 minus 50 and then divide by 2.
Yeah, you just take the average. That's all you do. Negative 50. Well, how do you take the average of two numbers to see what's in the middle? You add them and divide by 2. So it seems that to get the maximum total apples, I want to plant 15 more trees. Because what that does is the number of apples per tree goes down, but I'm getting more trees. So that is the sweet spot. Each tree is making less apples, but it's overcome by the fact that there's more trees. If I go past 15, my number of apples starts to go down because now there's not enough resources for each tree. All right. That is an immediate real life problem. I will admit it's simplified, but that's a real life problem that finding the intercepts helps us figure out something very useful. How many more trees do I want to plant so I make more money? That's a great question. I like it. Now, of course, if you have a business and you're like, I can't afford 15 more trees, I can maybe afford 7 more trees. Well, that's going to make it better. You're still going to go up a little bit, isn't it? So that would be the other considerations. And there's more variables too, right? There's the cost of fertilizer and there's the cost of water and there's all this other stuff. I mean, but this is basically still the idea. Okay, that's enough, Jeff. That's enough apples. That's all I want to talk about today. How's that? You guys all right with that? It's Thanksgiving week. What the hell? Good. Even if you had said you didn't like it, I would have said, I don't care. That's what I'm going to do. So if you need to hang out and ask me anything, let me know. Otherwise, you're free to go. So let me know.
Sometimes you can put a "oh well" before the "what the hell" there, Jeff.
Oh, what do you mean?
Oh well, what the hell?
Oh well, what the hell? I like it. It all works.
Bye. Have a
Everybody
good
all right?
Thanksgiving, man.
Take care, guys. Do what you can. Have as good a one as you can.